Somewhere in what is now Montana, 66 million years ago, a single Tyrannosaurus rex lifts her head at dusk. She is enormous, she is scarred, and she is, as far as we can tell, completely alone. No mate, no offspring nearby, no rivals challenging her territory. Just silence, broken occasionally by the distant call of a species she has never encountered before, because it hasn't evolved yet. What would it actually feel like to be the last of your kind without even knowing it? That question sits at the center of one of the most haunting simulations in modern paleontology, an attempt built from real fossil data, real sensory biology, and real ecological modeling to reconstruct what the final days of Tyrannosaurus rex may have actually been like. Not the roaring monster from film screens, not a special effect, but a living, breathing, thinking animal, experiencing the last chapter of a 79-million-year dynasty. And when researchers ran that simulation forward, the results were far more devastating than anyone expected. To understand why, we first need to understand who Tyrannosaurus rex actually was, not as a movie villain, but as one of the most sophisticated predators evolution ever produced. Tyrannosaurus rex appeared roughly 68 million years ago, in the final few million years of the Cretaceous period, across what is now Western North America. This wasn't a swamp-choked jungle like popular imagination often assumes. It was closer to
But size alone doesn't explain why paleontologists consider it one of the most advanced predators of the Mesozoic. What truly sets Tyrannosaurus apart is what was happening inside its skull. CT scans of Tyrannosaurus brain cases, pioneered by researchers like Lawrence Whitmer and later expanded through digital endocast studies, revealed something remarkable. An elongated, well-developed olfactory bulb, larger relative to body size than almost any other theropod dinosaur studied. In simpler terms, Tyrannosaurus likely possessed a sense of smell, rivaling and possibly exceeding that of modern vultures and wolves. This wasn't a mindless killing machine relying purely on brute force. This was an animal capable of detecting carcasses, or prey, from kilometers away, interpreting complex chemical information carried on the wind. But smell was only part of the sensory story. Tyrannosaurus also possessed forward-facing eyes, granting it binocular vision far superior to most other dinosaurs. Researchers led by Kent Stevens calculated that Tyrannosaurus may have had a visual acuity potentially 13 times sharper than a human's, closer to that of an eagle. Combined with excellent depth perception, this animal wasn't just powerful, it was precise. So here's the first mystery worth sitting with. If Tyrannosaurus rex had senses this refined, a brain this specialized, and behavior this coordinated, why, in the simulation researchers built, did the very same intelligence that made it such a successful predator ultimately become the source of its most devastating vulnerability? We'll return to that. But first, we need to understand how this animal actually lived day to day, because that's where the simulation begins.
Traditional depictions often portray Tyrannosaurus as a solitary apex predator, but fossil evidence increasingly complicates that picture. A remarkable bone bed discovered in Montana, containing multiple Tyrannosaurus individuals of different ages found together, has led some researchers, including Joseph Peterson and colleagues, to propose that Tyrannosaurus may have exhibited at least some form of social behavior, potentially even loosely coordinated group movement, though this remains genuinely debated among paleontologists. Not everyone agrees. Critics point out that bone beds can form through unrelated circumstances, flooding events, drought-driven congregation near water sources, or simple coincidence rather than true social bonding. The evidence is suggestive, not conclusive. Still, what we know with much greater confidence is that Tyrannosaurus almost certainly cared for its young, at least during early developmental stages. Juvenile Tyrannosaurus, sometimes nicknamed by researchers using informal names like Jane, based on specific fossil specimens, showed dramatically different body proportions than adults, leaner, faster, built more for chasing agile prey, while adults transitioned toward bone-crushing power, capable of generating a bite force estimated by researchers such as Gregory Erickson at over 30,000 newtons, among the strongest bite forces ever calculated for any terrestrial animal in Earth's history. Imagine that. 30,000 newtons is enough force to crush solid bone as easily as we might crack open a walnut. Around the first quarter of any journey like this one, I always find myself wanting more people along for the ride.
Now, let's return to that simulation, because this is where the story becomes genuinely emotional. Researchers modeling late Cretaceous ecosystems have increasingly focused on something unsettling. Tyrannosaurus rex appears to have existed in far lower population densities than most people assume. Based on estimates published by researchers, including Charles Marshall and colleagues in 2021, analyzing growth rates, life expectancy, and available habitat, scientists calculated that at any given moment, there may have only been around 20,000 adult Tyrannosaurus individuals alive across their entire range. 20,000! Across an area covering much of Western North America, spread across countless generations over roughly 2 million years. That means, statistically, an individual Tyrannosaurus may have encountered relative strangers of its own species far less often than modern lions, wolves, or elephants encounter members of their own social groups. Now, imagine simulating the final individual of that population, not through fantasy, but through actual paleoecological modeling, factoring in territory size, prey availability, competition, and the same sensory capabilities we discussed earlier. What emerges is something unexpectedly tragic. A Tyrannosaurus equipped with a sense of smell built for locating others of its kind across vast distances, eyesight capable of recognizing subtle movement from remarkable range.
A brain complex enough, based on encephalization quotient studies, to exhibit possible long-term memory and environmental mapping abilities comparable to some modern crocodilians and birds, its closest living relatives. An animal biologically wired, in other words, to notice absence. Researchers caution, and this is important, that we cannot definitively claim Tyrannosaurus experienced something equivalent to loneliness the way mammals do. Emotional experience in dinosaurs remains one of the most difficult, genuinely unresolved questions in paleobiology. We simply don't have direct evidence for subjective emotional states in extinct archosaurs. But we do have evidence for behavior patterns that, in comparable modern animals, particularly birds, Tyrannosaurus's closest living relatives, correlate strongly with stress responses to isolation, reduced territorial marking, altered movement patterns, increased risk-taking during hunts. Some researchers studying analogous behavior in isolated crocodilians and large birds of prey have noted similar patterns when individuals lose access to social contact for extended periods. This is precisely where the simulation becomes so striking. As the modeled population dwindled toward a single remaining individual, behavioral algorithms based on these comparative studies predicted exactly that pattern: wider, increasingly erratic territorial ranging, reduced efficiency in prey selection, and ultimately a...
Now, it's crucial to be honest about the limitations here. This simulation doesn't prove Tyrannosaurus rex felt loneliness in any conscious sense. It demonstrates something more measured and more scientifically defensible, that based on known sensory biology, known social architecture, and known behavioral analogs among living relatives, isolation would have produced measurable physiological and behavioral costs. Whether that constitutes something resembling emotional suffering remains, quite honestly, beyond what science can currently confirm. And maybe the deeper researchers investigate Tyrannosaurus rex, the less it resembles the mindless monster of popular imagination, and the more it resembles something far more complex, far more capable, and in this particular simulation, far more tragic than most of us ever imagined. If this exploration into the mind of the last Tyrannosaurus captivated you, there's another extinct creature waiting to be reconstructed, another set of fossils, another set of unanswered questions, another mind from deep time waiting to be understood. Join me for the next expedition as we continue uncovering what it may have truly felt like to be alive, millions of years before any of us existed.